Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 103rd question of the problem solving series and the 13th question of the topic tree. The difficulty level for this question is easy and this question has been asked in Meta, Google, Amazon, Microsoft, Apple, Adobe and many other companies. This is a very simple question. You must know what is binary search tree. So we need to search the element in a binary search tree. So what is a binary search tree? Binary search tree are those types of binary trees where for the root, all the elements of its left subtree are smaller than the root, right? And the right subtree elements are always larger than the root. And since you know tree is a hierarchical data structure, so it follows for the other thing also. That means for this node also, its left subtree will always be smaller than it, and the right subtree will always be greater than it. Okay, so this is the binary search tree property, and we are given an element and we need to search that element in the binary search tree. Okay, a value we need to search the node which has this value, and once we get that, we need to return that subtree itself with that value as the rooted value. That means if suppose I have been given 4, so in the beginning only 4 is there, so I'll return this node. Okay, if I am given here 2, so you can see the 2 is present here, right? So we will return this whole this node itself. That means roots left. Okay, so we'll return that whole subtree or tree is rooted with that value. Okay, so this is actually so here we will return this 2 node. Okay, so 2 node, once we return, it will be like this. So how we'll solve this? So you'll use that property. So when we solve that, okay, this is, we'll compare this with the root value. So you can see that 4 is actually greater than the value 2. Okay, so since 4 is greater than the value 2, so what do we want? We want our value to decrease. So to the right side, the value is more than 4. To the left side, the value is less than 4. So we will search, we will go to the left and we'll search with this. So now when we go to the left and we search with this, so you can use recursion or iterate anything. Say we used recursion and we went again called this function with the root left. Now when we compare this 2 with the given value, which is 2, it is equal, so we return this node. Okay, so we can solve it like this. If the question was given to find the value was 7, then you would have gone, since it is 7 is greater than 4, then you would have gone to the nodes right and you'll get it. If the value was given as 9, then we would have again gone to the right part of it, and then the right part, it's 7, again it is greater than 9, it's smaller than 9, so we would have again gone to the right part of it, but the right part of it is null. That means when we get null, we will return null. Okay, and we won't be able to find it. So if we don't have, we are not able to find the value rooted the value with the rooted in the tree, binary search tree, then we return null. Okay, let's solve this. Simple. So if root equal to null, we return null. Okay, what would be the time complexity? Order of log n, as simple as that. Okay, then if root val equal to val, return root, else if root val is greater than root than val, then what do? We call return, we call this function search bst with root. Since it is greater, the root is greater than the value, we will go to the left, right? And val will pass it else if this is smaller, if it is equal, we return this. So if it is smaller, root value is smaller than the given value, like for 9 or 7, so we go to the right, else return search bst root right val. Okay, we are done. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough session. The code walkthrough of the 103rd question in the lead code platform. Search in a binary search tree. The difficulty level, you can see it's easy, and these are the companies that have asked these questions. Let's look at the code. It's simple as simplest code. Okay, let's submit this. We have already seen the explanation, so yeah, let's submit this. So it has been accepted. Okay, see you also in the next video where I'll be explaining the 104th question of the problem solving series and the 14th question of the topic tree. Jai Jinendra.